Hey, welcome to Coffee Compiler Club. Here today to talk about compilers and language runtimes and module systems and anything and everything else that might be related to implementing languages here. Um, I want to shout out to guest last week, Eugene, on his compiler because that was a really strong presentation. Like the guy's done a lot of work to get an interesting compiler going. And we were just shooting the breeze before the recording started about what options and why he chose what he did. But the guy's done an amazing piece of work. Um, I've had a request from Cameron, who's not on at the moment, to go do something with modules, as if I know anything about modules. So I've been pondering them with simple for the last month and a half while I'm trying to rewrite things to make it work. And I have a document to share. Um, which let's see if I can do that here. And I'll talk through why did this not come up with a link? The great Google later, you should have linked that, I would have thought. So, me turning modules, hang on, I'm getting sun glare, that helped. Me turning module thinking into notes. So this is goals as opposed to an implementation. Like the implementation's headed this way and is kind of a reasonable far along, but it's definitely not done. So one of my big goals, especially for tutorial, is a one-line program is syntactically, semantically valid so that you can say in a file hello.simple print hello world. That's a valid program. That means it has a valid class and module. So in the, whoops, what did I hit? I hit the wrong scroll bar and it popped up front. Okay, here we go. Yeah, right. So in this case, the module comes from the file name. So the module is called hello. That's also the class name. And because you didn't say anything on the command line that says that you wanted to have any output directly, this is a run and gun mode. This is compiled and executed in place. This is like a shell script. So this is like the easiest possible minimal effort to make something that's valid code. And then I went down, okay, I do want separate compilation because, bigger programs need separate compilation. So there has to be something to do with separate compilation. So I have a file who I didn't quote here. Okay, I have a file who's got a structure in it, has some things, maybe it has some static fields, whatever. I can compile it with a -o flag and a build directory, and it'll wherever the build directory is. It doesn't have to be in your locals. It can be wherever you want the build directory, and it'll put a .o file that can be linked against some future date. Within this file, this is the big change I've been doing the last month, is I changed so that the things that are outside of a struct are class initializers. Class initializers have the guarantee, like in Java, they are run once on first touch. And then here's the struct that is the class that goes with this module. So files pet. So the class is pet. This is the class definition for pet. And you may have other things in the file. And then I want to have nested and structured namespaces. So let's see here. So I made a little bigger structure here. So I have a directory. It's got my repo. That's going to be where my module sits. Here's pet. Here's my build. I have some other repo. It has some other code. The concept on other repos is other modules is they're almost surely separately compiled, probably built by unrelated people. You're picking up somebody else's module to use for your benefit, but you're not making a separate module out of your project unless you intended to have a separation of concerns. So the goal of the module is to say, this is an interesting large piece of code, is a standalone thing. It has structure, files, and whatever within it. But if somebody else wants my effort, they'll pick up the entire module typically. This would be me saying I've picked up, Java util hash map or some pieces of Java util runtimes or a C or C generator or a tar generator or, an AI commenting, quoting thing, whatever you're going to do there. So within this pet file, I have a pet structure. That's the class definition for a pet. I have another structure that'll be nested inside because it's inside the pet file. So this is really called pet.vet. And then the other guy who's picked up my repo here has decided he's going to make a dog as a pet. He's going to make a snake. He overrides the default leggies. He makes a vet, and then he can say things about those and use them. And when he builds pet, you're going to say just like exactly like I did before. .o file shows up somewhere. But when I build owner, I have to add a lib here. Go pick up on my library line something else, some other repo, which is the build directory for my repo where I pick up the pet and pet.vet. So that's just separate compilation where a module is sort of the border of where you would pick up separate compilation. Um, Semantically separate. You can certainly, within a module, separately compile individual files. So let's go look at
So
that. Go
I
ahead.
have a question.
Yeah,
Um,
since I don't know
is
what the
there
hell.
any reason why you want to use modules as the boundary for your like compilation? Because what I was thinking is like the more you can cache, the better, right?
Well, no, for a large program where you might have a million lines of code, you need some structure. Now, how you make that fast to compile and fast execute is a separate story, and these all have easy answers for fast caching. There's nothing in here that denies any amount of caching. Everything caches easily. So the first step is not make it go fast. The first step is make it sensible to build a large project and make sure that it's possible that there's a fast story somehow. And there is. So it can be fast. Like I'm not designing it to you can't ever get away with caching here. So this will be fast. Um, that being said, the caching
But
was not my first thought.
is it if you change anything in a module, is it going to recompile like the entire module, or will it be able to like say, oh, you didn't change this function, so I'm not going to recompile this
Right,
function?
right. So that's the difference between fast and ease. And there is totally a way to make this go fast, but that wasn't my first thought. My first thought was here I want to have some structure. Now, is there a way to make it go fast? Absolutely. So one module mentions that it uses another module. And if they're all present and available on a command line when I launch something, then I know I can owner SMP here can say things like, oh, I'm already a built-in make system. I'll check the .o file for owner and see that it's up to date with the owner SMP. Oh, I have the lib. Did the lib change on me? I'll have cached in the owner.o file if I produce one. This one is not producing an owner. No, this is a run and gun. This guy will compile owner but pick up the module repo build without the my repo
So
without touching my repo.
are you putting the timestamps inside the .o file?
There are a bunch of ways I could do that. This is all about how do you get it fast. So a thing to do is timestamps in a .o. A thing to do is a hash, some sort of secure
So
hash in a
like
.o.
the Nix builder, for example. I don't do you know much about Nix?
I read it once in the past, so no.
So basically, one thing it's going to do when it spins up a virtual environment is it sets the timestamp to the Unix epoch and no time passes inside that container because it's trying to create reproducible builds. So you can't like if you're relying on timestamps, it might
You know,
like
I'm relying on the OS giving me timestamps on files and that some time passes from when I start a build to when I start another build so that I can tell the difference between when files have been modified by a user who's modifying files and wants to do time-based updates. If I touch a file, the timestamp changes somewhere, and that's what I'm using.
right. So I'm wondering if it might be better to do a hash-based thing because then that would give you the same like
It,
results. Because
it,
like
it's like I don't care right now. There is an answer here. One of them would be, yeah, hash. One of them could be timestamps. Maybe I make you pick and I have a default so you don't have to pick if you don't want to, and I'll let you pick if you do. That's a solvable problem.
I use timestamps. Never had a problem with my build system.
Exactly. I use timestamps, never had a problem. I have used many build systems that don't use timestamps that do have problems.
Well, are you putting the timestamp in the file or just using the metadata? Because I feel like those are two very different things. Because
Um,
if you put the timestamp in the file, then your build's not reproducible anymore. Because everyone builds it at a different time.
that's a separate thing. So for me, reproducible builds start by saying make clean and then do a make and then do a bit check. Oh, it came up with the same answer. Oh, done. And if I want to say this is out of date with that, and I can do it on the file metadata alone, then that's fine.
Yeah,
If I want to do something about one person wants to look deep inside another repo, and I don't want to eat the entire directory structure of the other repo, I cache something somewhere that looks like a cache timestamp someplace.
yeah. I think cache using timestamps for metadata is fine. I'm thinking of like if you put it in the object itself, then it would be like
Right.
every time you build it, you get a different binary because the timestamp part changes, which is bad in my opinion.
Oh,
Because
no,
you
no,
can't.
not that way. Oh, you're talking about the bits changed because the timestamps changed.
Yeah, yeah. I'm
No,
trying
no,
because
but
like
the bits changed because you. No, that's fair. Okay, yeah, I've been hit by this before a long time ago. I'd forgotten. Yeah, maybe that's a good answer. I'll check that decision before I do anything with it.
because yeah. So I was just trying to like I want when I build something, I want to be able to like, hey, if you build this, do you get the same result as me? And
Yes,
like to
yeah,
make sure that I've figured out all the things that can change or modify the build
yeah. The bit for bit
across different
identical
machines.
is a key thing. It probably should go in the goals somewhere. It's not in the module goals, but it goes in the goals somewhere. Um, okay.
You can consider your dependencies as a graph. There's actually a recent work that has done something similar, but for debugging purposes. And they are generalizing hashing that Git does. Only Git does Merkle trees because Git can rely on the tree structure. They had to generalize this for graphs. But it's cool because it's a relatively quick way to have an entire dependency graph
Yeah.
captured in your hash. So then you can really track, find granularity and do it relatively quickly.
I've been playing a lot with Merkle tree hashes of late, doing hashgraph.
All right, of
Yeah,
course.
yeah, it's a good answer. There's definitely a theme here that I want it to scale well. So I'll be paying attention to how it goes on the large scale. But I don't have any code, so I don't have anything to test on big. A few more odds and ends, and then I'm done here. I gave an example of a pet and a vet. The vet could be in a different file. So here the repo has the pet. If you have a pet directory, that means that things inside of it are nested inside pet namespace, just as I was doing in within the same file, but they're separate files. So the pet file has the same as before without the vet. The vet file is the same before, except it's moved down one layer in the directory structure. So now it's still pet.vet. And the owner guy doesn't change, doesn't know, doesn't care, can't tell. So you can start with small classes and structures that are all in one file and break it out later. And a consumer won't know, won't care, can't tell. Um,
So
if that,
what about the standard library? It will be included by default, but
yeah, standard library will be included by default, and I can pull the code up for that, which has started down this path of looking like I'm doing here. I have some files I've split up into depth, and some are in the sys, and it needs to break up and become structured. But at the moment, it's a little higgledy piggledy. But
because
I'll pull it up. We'll take a look at it in a
the,
second here.
the standard library will be one module on its own. It won't
Yeah,
be
yeah, as a
split
module,
it
right?
into. Okay.
Totally the
Okay.
goal. Standard library is a module. And you'll have to include it, but you'll get it by default. So if you don't want it, you have to say I don't want it. Like if
Mm.
you're building a standard library, you say I don't want a standard library because I don't have one. Um, Class initializers are lazy. That's like I have a parent who says, "Hey, print something," and then call out something from B, but not A. And then A says, I have an initializer for A and I have an initializer for B. And you notice I'm not giving any struct definitions here. So these guys have a CL init, a class initializer that's a run once lazy. they have empty definitions for child A and child B. They're structs with nothing. And if I run the parent code, this guy here, he'll run the parent init first, then he'll run the child init, and then he'll run the code in the parent. So this line runs, we stop and we init B as a child of parent, then this line runs, but never does the A code run because I don't mention it in the parent. That was one of the big learnings from Java is that, libraries pick up a lot of crap and a lot of crap is never used. And you don't want to actually initialize and deal with setup and running of things that are never used. So you have to be lazy on the class inits. In the C world, the class inits all turn into like hard constants. They don't actually in C++ they run once. And in C they're hard constants. So the initializer is just like pile of bits in RAM. It gets loaded from disk into RAM. C++, you do have this lazy initializer thing going on. I screwed around.
Well, in C++, they're only lazy if they're static inside
Yeah.
a function. If you put them in
Yes.
global scope, they run at the program
But
starts. They're not
but you can
lazy.
have static globals and then they're lazy,
No.
which means
If
somebody has to do a runtime
if
check.
if it's a global, it's done at program startup. It's only
Oh, it
lazy if
is. Yep.
it's
Yeah.
like if you put a static
No.
variable
If there's
inside
a
a function.
constructor, it's I believe it's lazy. I
Yeah, I've
think
done
it's
this
locked.
recently.
No,
It's in
no,
the
no. Anything
constructor.
anything that is in the global scope runs at program start. If it is inside of a function and you
Yeah,
declared
in a
a
function.
static variable,
Yeah.
that's lazy.
Right.
But if it's
That's
global, it's put in a linking
ah
section, and when
right.
you
Okay. So if
there's
it's
like
in a
a table,
function in a static variable, it's lazy until you first touch that function.
right? But
Right.
if it's a
There's a
global
way to make
variable,
them happen.
if it's a global variable, it's done at program startup. So there's a
But
table that it generates, and then in the init function, the runtime look runs through everything in that table.
No,
And
no.
that sounds right. I just usually have constant expression on my globals.
Right. But I've totally done the thing where you have a static variable that was
Yeah.
then
yeah,
lazily.
there's another exception, which is if it's something that is like a primitive type or a static constant expr, then it will do it at compile time instead.
C++ has a lot of exceptions in a lot of cases, and I don't think we
All
should be
right.
talking about that.
I find the CL init behavior useful in Java to get you some initial things that are going to just be constant for all time. So it's a run once and save things off. Um, golden instances and all that kind of stuff. There's a bunch of things you do there. So fine. Uh, I don't. I'm looking at using underscores for making things private fields, whatever. That was a throwdown. I need some sort of namespace control. And then here is me compiling the sys guy for x86. No run means I'm not going to execute it. I have an output, and it's going to be that named file, and the two libs don't count. That's a typo. And source main simp is just the directory leading up to the module, which is going to be sys here because I didn't specify a module start. So there's a missing command line syntax that hasn't hit here yet. Is basically there's a way to specify a root of a module and then path relative to file within it if you want to compile one of your files within a module and not the whole module per se. Um, you hack a file, you compile a file, you get the one file compiled. If you have dependent files within the module, I haven't decided if I'll force update them on you or not. I probably will. It'll make life easier if I do. But mostly that's it. You're gonna throw your modules on the command line to say go find my lib somewhere or my set of libs. There's a path that whatever. There's a collection of libs here, and then the guy finds your bonus names. So in C, it's the link line. And in Java, it's your class path line, list all your jar files. Same kind of deal. That's that. Why don't I go to find standard lib, which is very lame, but not completely empty. So there's a sys file and a sys directory. So standard lib is like whatever. Sys is my standard lib. And I have some junk in here. So here's like libc bindings so I can link against libc. Like mostly I need to have shit like read and write to do IO. And then I have an array utility that's just array copy as a standard thing that's nested inside sys. So sys.array.copy will get you a copy function. So this is a struct. It has one field. The field is a final constant because code is constant. Because it has one final constant field, because it has a final constant field, it's moved to the class array. So instances of struct array are still empty if you were to have an instance of struct array, but there's no point to it because it's an empty instance. That's array copy. Here is a vector of bytes, and it just has an underscored named grow function to double the size. And then you can add a character, and you can add an array, and you can undo to roll back and forth, and a parser, and I'll probably have some other stuff. And here's a shortcut for a write that just throws it out on whatever file descriptor you give it. You give it a file descriptor, and he does the correct write call. Here's a fancier scanner that does white space parsing and number parsing, and I was using it for writing fancier code programs or test programs. Array of integers. I haven't got generics yet, so I don't have an array of generic things, but do that. And then the reason I'm here is actually to look at the nesting. So sys has a bunch of structures within it. And I started, oh, this is a stale. Damn it, I thought I had this cleaned up. I did not. Or did I just not go the right place? Hang on. Here. No, here. So this is sys.io. You'll notice it doesn't say class or struct. That's stale. It should say class IO. But then it'll be oh, it doesn't have to. Right. Okay, these are CLNets inside the IO. So sys.io.p, this is a static global variable p who has a function that takes a string and prints it. And here's a read from standard in, which just reads from standard in until you have all the bytes of standard in as an array and returns you the array of standard in bytes. So you can just say sys.io.standardin and you get back essentially a string with an array of bytes. That's whatever's on your standard input. So that's it, other than its namespace. That's IO is inside the sys namespace because it's in the sys directory, and that's the root of my module. So the module root is this directory with the sys, and within a sys subdirectory with a sys SMP, and within the sys subdirectory is a nested set of, and then nesting can go as deep as you want.
So how does it know if you refer to the sys.io, that would be inside the directory, or another struct inside the sys file, the sys.smp? How can he disambiguate the both?
Let me hang on. You're talking about, where's my module? I need to open this up in a separate.
Mm-hmm.
This guy, when he says this.
Yeah.
What are you asking?
Sys.io, it will search inside a directory sys, and it will search for .io.
Okay.
But if you refer to something that it's inside the sys SMP file, another class maybe, the SMP file.
Let me go.
It has to have some priority in where to look first, because both.
Okay, so you start on the command line of your list of modules,
mm-hmm.
and you look in each module in order until you find a hit for the name, and the name is sys.io.p. There will not be another sys allowed on the module on the class path.
Okay.
The first one will shadow.
Okay.
So if you have multiples, the first shadow. So the first sys you find.
Mm-hmm.
Having found a sys, you look in it, and the sys can't have an IO in the sys file and a separate IO file that's nested one down. Right?
Yeah.
I have that's a namespace collision, and the module compilation will blow up on you and say, I have two syses. This is ambiguous.
Okay. Yes.
Pick one.
Okay.
Okay. So does that answer the question?
Yes. Yes.
Okay. So the output of these things then gets thrown into a .o file with a special section in the .o file that has the names in a nice hash table, so you can do a fast lookup. That is to say, I'll go to the module for sys, pull up sys.o, go to a special section in it, have a hash table, look up sys.io.p, get a hit or a miss. And that's it.
Okay.
So in theory, you'll open every module once on the command line as you lazily hunt them. And within them, you'll open up a special section, and that'll have a hash table which you'll load, and then you'll probe the table. After that first work is done, all future probes will be RAM table probes, hash table probes to go find names. So in theory, it should go really fast.
Okay.
Yeah, you were worried that I had multiple syses on the command line or multiple IOs within a sys.
So this is like let's say a global namespace. All the names must
Yeah.
be unique. Yeah.
The global module names have to be unique. That's right.
Okay.
And that's true for everybody that I know of. At some point, there is a global namespace. Doesn't matter, no matter where you put it, but there is a global namespace. And generally speaking, on your command line for firing off a compiler, whether it's Java C or CC, you give that list of global names. It's pound include header list, or it's a -L library list, or -class path list, or whatever. And then those names are searched in order. Typically, you allow duplicates, actually. You just search them in order. First one wins. It's the usual story. I could have it blow up and say you can't have dupes, which I think would be probably more trouble than it's worth. I think people are generally resigned to living with dupes. Like if I grab a module that somebody has tried to link other things in with, and I say a module, but say I've grabbed a collection of modules in a char file, basically a jar file like Java's jar, collection of modules. And then I have another jar. It has another collection of modules. And there's dupes. And there's the same fucking module duped 3 times over. DLL hell, right? It's the same story.
Yeah. Yeah.
Now
But picking the first one you see.
Yeah. This is where I want Cameron to come through. He has another set of concepts.
He says that he's stuck in the snow somewhere. So that's a future question.
What?
He's stuck in the snow somewhere. So that he mentioned on Discord.
He's putting version numbers, fine-grained version numbers. I don't know what he does if somebody claims they have the same version, but they have different bits. So, and in his fine-grained version numbering schemes, different modules can ask for different versions of other modules. So I know that my module works well with version 1.3 of this module and breaks with 1.5 because they fucking did a non-backwards compatible change. So I need a 1.3 of this module. As a complicated way of saying a module name, the module name has whatever name it has, plus has a version 1.3 attached to it. And then there's a 1.5 that somebody else wants to use. And so both of them are present and available. But I'm going to use the 1.3 version. You're going to use the 1.5 version. And then he has more structure involved in how he throws them into their private containers. And that prevents the 1.3 and the 1.5 versions from cross-polluting each other. Like, suppose they typically normally have global shared data within the 1.3s and the 1.5 that would have global shared data that they're doing things with.
An easy way here is to just prefix them another global prefix like the version. It will be enclosed.
Right. If I have I have the foo module, the SSH version 1.3. Then internally I just prefix them all with the 1.3 SSH, and they're all different names now than the 1.5 SSH. And so all names get prefixed, all names no longer collide, and you can have both versions running simultaneously. And if your code calls other code, and some of it calls the 1.3 and some of it calls the 1.5, that's in theory supposed to all work. other than the 1.3 and the 1.5 guy aren't talking to each other.
I'm not actually called for a rename. I'm more akin to the module. It will be like it will be like a directory of version 1. It will be silent, and if you put another version, it will be version 2, and everything will be prefixed by that, not a rename for SSH. It will be silently foo.v1.
Right,
Whatever
right.
you
It's
want to put.
silent. I
Yeah,
agree that one. That makes,
yeah,
yeah.
yeah.
Yes.
But essentially the same thing. It's a bunch of ways we can go about that. Yes.
What is Matt saying? A graph? Oh, this is the Merkle trees. Yeah, I'll take a look, Matt. I mean, this is, I mean, like I said, I've been staring at Merkle trees recently. Is that under the docks?
Yeah.
Yeah. We can go, oh no, this one. Research paper time. Do I want to share? Yeah, I don't want to read it all right now. Fine. Yeah. So there you go. No Cameron. He didn't see. That's all I got on that one. I've got the redo of the seal init and the init done. That was a big piece of work. And I'm probably have to do some touches to my sys file to get it to parse. It doesn't parse right now for stupid reasons. At least one of which is name lookup has failed because I don't have something structured right. And one of them is I think I just have to change some of the syntax in my sys, my standard library for a little bit. And I can save and restore IR and types in the .o file and a standard elfie.o file that I can link with as well. So it's getting together. It's not done, but it's getting there.
Nice.
Well, if you guys want to make fun of some Intel assembly, I'm ready for that.
Oh, pile on, dude.
Yeah.
All right. I'll paste the link in the window and in the doc,
Hit the share button
and
here.
you can open that up.
I'll open the doc up. Yeah, that makes more sense here. Let's see, share. Go back to here. Godbolt time. All right, Godbolt's always
Okay.
fun.
So you guys should help me remember because from what I remember, people used to make fun of GCC a lot, and they would claim other compilers, including Intel, is good. But every time I look at the code in like the last few years, usually GCC is the best one. So I don't know what happened, like to the other compilers or to GCC, but
I mean, I don't
yeah.
know either, but I'll say there was this time when GCC forced every other vendor on the planet to up their game. That was a while
Oh,
ago, and GCC was widely considered as horrific and better than all the alternatives, like democracy. It's the worst possible form of governance except all the rest.
which decade or which 5 years?
Yeah, 20 years ago. And
Because I
then,
remember.
people upped their game. And Intel's compiler in particular got a good reputation. I mean, Matt should pile in. He's got the same kind of background as I do on this stuff. And then, now it goes round and round, and new chips want new things. And these micro benchmarks are kind of questionable in the sense that no one's real program really runs faster or slower based on a one clock cycle. I did this or that. Okay. But you want to say over a large corpus of big giant programs that run for a long time, how well do the compilers do? And then sometimes that boils down to, oh, they fucked up on some tiny case. I don't know who put the video out of that Splash guy talking about using dead code elimination and watching GCC and Intel's compiler or Clang take turns not finding obviously blatant dead code. That was a fun
I've
one to
never
watch.
seen that one.
So what do you got here? You have
Uh, okay,
Recon.
so what I was trying to do was I knew a piece of code that I was going to have in a hot loop would use bit fields, and I remembered bit fields were not optimized well. So I just copy pasted some example code I had laying around, and I checked, and I saw that like GCC used move absolute, like a big literal and an and, which I thought was unnecessary. Clang is similar, but then MSVC was worse and ICC was much worse. Actually, yeah, I don't know which of the two was the worst
Let
worst,
me
but
let me let me.
Just a point of note, you are using a version of ICC, which is end of life. You are probably noticed it's 2021, which is nearly half a decade ago. The current Intel compiler is called ICX, and it's based on LLVM with proprietary extensions. So go to the newest IC. You can just type ICX.
the thing is, it gets me.
ICX.
Oh, X.
Uh, yeah,
Yeah,
Oh,
and go to the latest. And then it's
25 Freeman.
probably gonna be pretty similar to GCC.
Oh,
it's
yeah.
exactly the same from what I when I looked at it earlier.
Because the other one was like almost half a decade ago.
So
Yeah, I
2021
want.
was from okay. This is a from scratch new compiler from Intel.
Yeah, that's one is
No,
LLVM based. So they have a fork of LLVM downstream. It standards with proprietary patches and then release compiler called based on that. ICC
Gotcha.
is classic, which is not LLVM based. It had
Okay.
pretty decent loop optimizations, for example, specifically loop optimizations, not necessarily
Oh.
amazing for Scalar code though.
So I'll note that the Clang 21.1 here and the ICX code are identical. So makes sense that if it's downstreamed from Clang, it just produces the same answer
Yep.
here.
so the reason why I brought this up today was I was just like wondering because it's to me the okay, so test and test two is the same code. It's just written differently. I thought that like all the compilers would just treat them as the same, but it's definitely not the same. And I don't know why bit fields are treated differently. Maybe they don't have the concept of just using a few bits and they have to like do some weird hack around it. I don't know, but I just thought all the compilers would produce test two, but yeah, they produce
Yeah, I
random
don't
code.
know. The semantics of bit fields are not anything out of the ordinary, right? They're just they allow bit sharing and all kinds of shit, right? They're just a wad of bits. You're wondering why didn't they pack them into a 64 and then do 64 wide things, which is what your test two is doing. You know, you just
Well, yeah, one weird thing was I noticed that in test it would use an and with a large literal, which is I think every
yeah.
bit except for the high bit is cleared, or every bit is set except for the high bit. But anyway,
Somebody was
it's coming from a U32, so it should have known that already. That's the weird thing. Like,
uh,
why didn't it know that? Like, I don't know why. I thought all the compilers would recognize
I'm
that.
sorry. Oh, it's coming from this U32.
Yeah, like
Uh,
the code is similar. It is not going to have performance problems, but
I don't
I'll
know.
like if I'm looking at hot loops and I'm looking at
For
optimizers.
C2, I did very specific targeted optimizations in this kind of, there's no bit fields in Java, but people and mask all the time. They fake bit fields by and masking. I did very specific optimizations looking for things that could fit into 1 byte, 2 byte, 4 byte, 8 byte patterns because there were hardware ops to accelerate those. But I didn't do a whole lot of generic bit field hackery optimizations.
You always kept an upper bound, so I thought maybe that's the solution to this. And surprised that GCC and Clang are not doing that for test one. Or
I have to stare again at your string adder like the source
Wait,
Yeah, I think
caches.
I remember
can I?
about heat fields that they are kind of underdefined. For example, they do not even guarantee that you are going to have a packed layout. So you cannot even rely on the layout being as you thought you specified it is. Generally, I have heard bad things about bit fields, particularly from people who would think you would use them, embedded developers. There
Yeah.
are caveats to bit fields, to say the
What are you?
least.
What are you expecting the optimization that it would do is?
oh, I was just like
Well,
weirded out that it didn't know that the U32 cannot have the high bit sets, and it's clearing the high bits. But
right. This is the
Cliff, you could
giant
just close. You
giant
can
and
close all
mask
the
for the high bit
outputs.
seems excessive.
I mean, so the U32 can't. Why can't it have the high bit set?
No, no,
because it's a 64-bit
it's a
variable.
64-bit thing. You should be zero extended into the high order bits, into the upper 32.
Oh, but that only works if it's inlined.
Right. Well, that's the attempt being done here. The length field is being passed in. Where the hell? This is why the window's too small.
Yeah. You can just close all the compiler outputs because we only need to look at the source or just one of the
Just one of
outputs.
these. Yeah, so string adder here is picking up the length field for the count, right? So the count under is showing up as the big thing here. He's passing it as a U32. It's a 59-bit field, so you would expect him to add on whatever 59 minus 32 extra zeros as part of the shuffle and build. And on test two, this is what it looks like. He's taken the length field, he's shifting it by 4. It's all zero filled anyhow, and then he's going to set the reserve bit and store it, and you're done. I think this is like, I mean, obviously it's pretty darn obvious. Or here, this one says make a giant bit field. Oh, take that length and shift it. Okay, as a 32-bit thing, shift it up into a 64-bit thing. All the upper zero bits should have been zero already. Now and mask off the upper bits. That's what I'm with Levo on. I'm kind of like, wait a
Yeah.
second.
I think that's an AVI thing because like it's only able to use the first certain number of or like the bottom half of the register because I believe the top half of the register could be used for like other things.
Maybe. I mean, here
You
the
could just do
output
a move
says
for.
unsigned long. Here he's like U32 is somewhere in the compilation
Oh
process.
shit!
The binary
I copy
decides
pasted
he's
wrong. We got to try this again. Can we look at line 2? I messed that up. I did not realize.
oh,
I
dude.
I don't know if it happened in my code and I just copy pasted wrong. But
Unsigned long
okay,
is
good.
also
No, I
also
think it's int. Try int.
Unsigned int, right?
use
I'm
uint
gonna feel
32.
really dumb if I could have sworn I saw it in my code. In my code, it was not typoed. Oh shit.
Da, da, da,
Well,
da. So the compiler's not quite as dumb as it looks.
I didn't believe.
Happens to the best of us.
uh, I
Plus
really
one
want to
point
see
for Intel
other.
compiler.
I'm going to reopen this and check other
But no,
documentation.
so why is test two okay? Oh, because you just said, oh, just don't do bit field things. Just shift that sucker by 4, and it shouldn't have had any extra bits, so therefore it's okay. Yeah, fine.
Okay, so I just looked at the other compilers. MSVC and ICC still has the bad ones, but um, in Clang they do a move extend. Actually, both of these are
Where do
both
I? How
Clang
do I
and G.
add a window now? I've nuked them with the X.
Or
Where's
you
the?
know what? I could just
Oh,
do another link and paste it in.
I'll just reload the same link. See if it comes back to me.
I
Oh,
don't think
okay.
it's
Let me. I'll just pull it out of the doc. Hang on. This should give me all of the things. Right. Okay.
okay.
So
I
now I'm
just
going
put
to
it
go
as
here.
5.
Mm.
And MFC is sucking.
This is why we use standard uint
ICX.
32T.
Hang on. I'm sorry. I didn't hear you, Ryan. Let me get ICX going here too.
I said this is why we use standard uint 32 underscore T.
Yeah. Well, if you're hacking around, you sometimes make a mistake here. But what happened with MSVC? I got. Okay, let's see if I can.
No, MSVC doesn't have -02. You gotta do like /z something, I believe.
Yeah, you also don't have a March
Oh,
native. You have to pass the CPU completely differently.
Okay, wait a second. So
see,
he said
I program in the
O2
night
March.
sometimes, so don't always
So,
pick
so what?
things up.
That's not the right compiler flag.
Yeah, somebody tell me different compiler flags. I'll do something different here. He says
MSVC.
unsigned. Oh, comment. Oh, come on, scroll bad.
It's
/O2.
/02 maybe?
I'm sorry, what?
/02, I believe. Not dash. There's no dashes in MSV.
You mean this?
/02, and there's no March equals native. What is
Try
it?
/r:\avx10.2. I posted this in the chat.
Oh, in the chat.
Great.
Ay, 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 ay. Let's see here. Too new. This guy. Okay, I know what
FYI,
to put
Ryan.
down.
So the reason why I did it this way was because in my code base, I don't actually use any of the standard.
Somebody hate
Like I don't
code.
use any standard C, don't use standard C++. It's just all my code. So all my code is written with U32 and U64.
Where do I
I
get
just
the
copy pasted wrong.
where do I get the output failed? Output compiler invalid what? No, he doesn't like your arch flag there, Matt.
I don't know if you necessarily need it because we're not writing like SIMD.
Should be supported in a pretty old one. Strange. You can try like AVX512, one word.
Okay, he didn't
But
slash, I assume.
the easy way
Arch
to check
colon AVX512, like that.
an
That's
easy way to check if this is optimizing is just write a new function and have it assign like int a equals 5 and then return a and see if it returns 5 directly. Like that's what I
well,
usually do if I want
he's
to double
not
check.
doing all right. Okay, so come back over here. Boy, no, int test3 takes no arguments, says return, oh, says
No, int a equals
a
5.
equals
You can also
5.
try OX
Return a.
to enable mode speed optimization instead of O3.
Okay.
It doesn't have O3. Only has O1 and O2, but try OX. Yeah,
Okay.
that's it.
So hang
Oh,
on.
yeah,
Down
slow
here
down,
in the
keep
land
going.
of 5, here's your return of 5 directly. Oh, test 2 is looking good.
Huh.
But test 3 here is just like, I don't know what the hell happened here. That's the constructor call. This is test plain. He says, do horrific things so I can't see. So let me close windows and scroll wider. He says, what the hell this is? And with minus 15. Well, that's a smaller way to say low bits or something. Minus 15. Is that going to be all high bits and the low bits all zero? Yeah. He just masked out your free kind counter. He set your bit for reserve as 0. And now comes an amazing dance. And here it is, the bad giant constant.
Wait,
What the hell?
I'm very confused because how did it do the bit shift?
Well, that's a good point. You have to be at least like 5 shifts or something, right? Like assuming one of these grabs. Oh, this is something of a register or as a register or something. What is this? A SIMD as a register? No, it's not SWAR. What's
If you
the?
look at line 30, it shows that it's a constant, but I don't get it.
I think it's being very clever. It's like, I don't
Yeah,
want to do
more
shifts.
clever
They're
than
too
me.
slow.
Is
I don't know
being
what he's
too
doing.
clever. Too clever.
I mean, here is store something down, load it from here, and store it again. Like, is he shifting by writing it to memory and loading it back up over at a different offset or something? You
But
have a
that should be
5-bit shift for the count, right? You have low reserve. Oh no, the free kind, it could be a 1-bit shift or it could be a 5-bit shift. Depends how he does the layout. In your manual layout code, you designated that you shift by 4, not
yeah.
5, so the high bit is not whatever, not low. That's fine.
This is comedy right here.
I compiler comedy. Yeah, I don't know. Here in the good code for this test guy constructor, he does the shift by 4, and then he
This is
increments
Clang,
your
so
reserve.
this is Intel Clang. I rather see the old Intel as
I have
other
to run
comedy.
this through like an x86 simulator on slow mode to figure out what the hell he did here. He stored something down. He then loaded up RSP plus 4. This is like
That's
a
4 bytes. I
misaligned
don't think that's
load
bits.
of a value or something crazy.
Could be the conventions of calling conventions in Windows, passing more things on the stack or something like that.
Ooh. Oh,
There's
you
no
think he's
call though.
passing string adder on the stack? No.
But test
I doubt so.
receives arguments. I wonder if it's one of the arguments that test receives.
Jeez. Well, I don't have bit fields in simple, but I'm curious if I take your test 2 version, what I'd show up. I think it would be pretty obvious.
No, because it would do the same thing in test two if that was the stack argument by the ABI, but
Right.
it's not.
And it's not.
So
Yeah, he's D-word storing. He's storing low bits and then high bits. And the high bits are, oh, he constant folded you, maybe. He pulls up 40 and he says, I inlined test with length of fix. Where did you get a length set? How can he do that? No.
I think this was just an excessively clever bit hack that shouldn't have been used in
I
this case.
I haven't even figured out how the excessively clever hack works yet. I'm agreeing it's excessively clever. I can't even figure out how it's working yet. All right, fine.
Well,
Um,
that add 24 is probably a hint.
I'm sorry, which add here? There's an and. That's your mask. Move or. Here is he rebuilt the whole thing and
And
shoved down.
put
Oh,
it
that's
put it
just
in
another
Chat
hack.
GPT and see if it can explain how it works.
I'm sorry. This is like if I throw it into ChatGPT, do I expect to get something readable, visible, sensible out, or do I expect to get something subtly, stupidly wrong?
I actually have to go, but I will check the YouTube videos so I can laugh about
Well,
this more.
throw in the ChatGPT discussion of this code pattern in the in the Discord too.
I'll see you guys later.
All right. Bye. Fine. Okay, that was a fun go around on stupid compiler tricks. Um, I'm certain that I have fallen into these traps before, but it's been a while for that one. That was entertaining. All right, somebody else. What do we got here? No one else has any news of the day. No updates from Simon on core.
Oh, I was kind of successful in compressing the header bits of my objects in core, but nothing big to show. And I'm currently reading the existing garbage collection code and trying to better understand why we have a type word
Mm-hmm.
that has a bit reserved
Mm-hmm.
for a forwarding pointer. And if the bit is set, then the type word is treated as a forwarding pointer. But we also have another forwarding pointer next to it. And
Which GC is this?
it implements multiple GCs. The original author wrote his diploma about it and benchmarked various things. And my assumption is that it has both approaches in the headers because some existing algorithms worked one way and some worked the other way, and he just implemented them straight the way they were intended to, and merging them just wasn't a
Wasn't
task.
worth it. I totally get that.
So yeah,
Giant pile of extra work.
so
No.
I, I can't compress the headers yet. Well, I
Right.
made the type word, the type pointer work with 24 bits.
Yeah.
And well, if it turns out that the forwarding pointer works without needing a complete separate word, I guess most of the effort of compressing uh, the type pointer was not necessary, because then I can just use the bit that is either 1 or 0, and then determines what the bits before them actually are, but it happens. It's interesting. I'm not complaining. Oh, and
So
I replaced all the usages of libc in core with or like the direct usages where libc was written directly down as a function with rustics, which is an abstraction that either
link.
calls
This is like
the kernel
not using libc to get
directly
syscalls.
or goes through the VDSO. So at least at this layer, I'm now free of going through libc, which I prefer, and I'm happy about it.
Okay, what's the name for this rustics thing?
Rustix, rustics.
I'm
Basically,
attempting to find it. I'm getting all kinds of fun hits.
let me have a look.
I have a GitHub link if you have a better one, like an
No,
org.
I think that's the one. I'll post it in the chat.
It's Rust based, which is
Yeah,
obvious
yeah,
name.
and it's basically a Rust binding for POSIX-like or Unix-like APIs, and it does not go through libc, but you can use the kernel API more or less directly, which is basically what I want
Have
because
this
I'm not writing C. I'm
here,
not using libc.
here. There it is. Somebody beat me to it. Couldn't find the right window. Fine. Yeah, because I was wondering um, is there any way for me to skip going through libc? Well, I'm not going to go through Rust, go to libc to avoid libc, but it would be
Yeah.
interesting to not have to pull in a libc just so I could get myself unattached
Um,
from libc. But
the alternative to
sorry.
that is probably Ape, the actually portable executable project. They have, I think, C
Oh,
or
thought they
C
were
header
like
file based
they have okay.
stuff. At least I think so.
Actually, portable execution. Yeah, I think I've seen this before. Seen this as the startup. This is like hysterical as a web page. Let me make sure the link goes in. If I can now find the docs. Da 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 da. Let me hit the share because this guy does a funny thing. I think we talked about this just last week though, or the week before. Recently, we've talked about this recently. Actually, portable execution. Yeah, I knew this hack existed a long time ago. This guy's gone official on it, so he's
It's Cosmopolitan. Yeah,
in the last couple
is the
years.
header library called. And
Um,
I guess the basic lesson from it is if you use enough flags for GCC, you can do a lot of interesting
you can do
things.
anything you want. So he manages to get like I would love to have the output binary that runs on all different kinds of things. At minimum, some version of Linux, Mac, and Windows. You cover the big ones just straight up, and all you need is some stupid little bits in the beginning to like figure out what the fuck you're on, which OS, and then just walk away from it, and you're done. I guess you probably have some screwing around on Mac to catch ARM. And then after that, everything else just like you're in. You still want to be able to link and execute. So I claim you want ELF and probably Mac O. Um, but you're saying he has bindings to the syscalls that are portable, that are not libc bindings?
I think they have the most complete syscall table I have seen.
Huh.
They basically just know the syscalls for every operating system and how they need to be, how the different numbers need to be mapped to the functions they provide and stuff like that.
Oh, this is actually the code of something. Okay, it's not necessarily what we want, although it's kind of hysterical. Yeah, I mean, sort of a long-term goal for me would be to say, yeah, I don't need libc. Long-term goal, not right away.
Mm.
Da 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 da. And then, here's where you have to go from here. And the $2 bill with the lemur. I'm sure I
Yeah,
need a $2
I
bill.
mean, I
Finally.
also want to get rid of libc as a long-term goal. The work I did on core recently was just a tip of the iceberg, so it was just a
Yeah,
direct
right.
usages. And of course, I have dependencies and Rust standard library all over the place that's still using libc, but I mean, I stopped adding more libc usages, start reducing it, and I'll chip away at it over time. And at one point, I guess I will find the last usage, and then that's it.
Okay. Uh-huh. A world without libc. What can it mean?
Yeah, I mean, I'm not writing C. I'm not interested in C. I don't want to use C. Why would I have libc in my memory? That's like I object to it on
Uh,
ideological grounds to
world
start with.
beyond POSIX only. Uh-huh. Yeah, these things are going to be one step at a time.
There's been actually a great talk about this that also is illustrating what is being done in OCaml. And there's quite a lot of things like how do you support I/O? And you definitely wouldn't want lowest common denominator like POSIX, because Windows is very different and it has been very different for a while with overlapped I/O. Actually, Windows anti-kernel is pretty good, which is maybe surprising thing to say, but it is pretty good. Linux recently has got an IO U-ring, which is very different from the POSIX tradition.
Yep.
And macOS does something completely entirely different. So generally, if you go for POSIX, you will not have a good support for Windows, Linux, or macOS,
Mm.
which is quite a big
Yeah, I
size
mean,
of operating
if you're
systems.
trying to find a shared or common API, picking POSIX or something Unix like is the worst choice you can make. It's just throw 90% away and do things
To
better. And
be
I
fair,
think
you will
you,
still support BSD quite well.
sorry?
To be fair, BSD is maybe still a good use case. It's So if you are going for BSD only support, like FreeBSD, OpenBSD,
Yeah,
NetBSD, then maybe. But anything else, or not.
Yes. Doesn't sound like the
um,
right thing to do.
I
Fine.
don't care about the BSDs.
Why? Why is like never mind. Why is POSIX being POSIX? Fine.
But I think
Who
there was an interesting article recently about the which parts of libc are actually useful, and it's it's not looking good for
It's
C.
just like
Let me
there's like
find
20
it.
or 40
Ah,
calls out of libc you need,
it's
and then
like
everything else seems
my review of the C standard library in practice.
yeah, fine. Oh,
I
another link with the links.
I sent it in the Zoom,
Yep. Now copy and paste or
and
somebody will beat me
the
to it.
site the blog of that guy is pretty cool in general. He has lots of interesting articles, and
Heh.
that that one I found that quite useful because it goes through the different categories of
libc.
things libc provides and says whether they are worth it or not.
Yeah, barely worth using. Assert and abort. Yeah, I'm going to have asserts and simple, and they're not going to use the C version of it. That's for sure.
Yeah, and
Um,
it's
yeah.
and but I mean it's cool. It goes through like your asserts, math, characters, and then you have like a quite a nice categorization of things and
Well, these are all things that I would just have somewhere in a standard library, but they're not top level. They're in a character class that's got a bunch of functions to break out. Yeah. the usual
Yeah, I mean,
characters you can
none
use.
of them understand Unicode.
And then I would be having them have Unicode brains.
Um, and I mean not they don't understand Unicode in the sense of they are limited to ASCII, but they actively break if they uh, receive something which has like more than 8 bits in it.
Yeah. Okay. This is one of these funny deals here. In my head, I'm like, I'm going to have a pile of bytes, and I'm going to call it a string, and it's going to be UTF-8. And then there'll be other classes that do all the other flavors of people's favorite versions of string Unicode things to deal with special cases. Because for me, or at least, the common thing is still to see UTF-8. Um, oh, he's got some hack with F get C. Oh, because he's doing end of file. Okay, fine. Yeah, so he's going to make some good points. Oh, and error no. Oh, geez. Yes, do not do error no. I don't really want, don't do set jump, long jump. Throw, try, catch. There's something to be done there, but not set jump, long jump. Kind of depends, I guess, where your goal is. It's definitely not my goal
No,
to,
okay. That's this article is does not understand computer architecture. They're saying atomic is a property of loads and stores. That is not true. There
um,
are
yeah, there's a funny deal.
I think you can
Atomic
argue it.
is
there
is an
there
agreement
there
between two different cores about what wrote and what you read, what I wrote and what you read.
so there's one huge elephant in the room with arguing that an atomic is a just a property of the load and store, and that's that for some architectures the alignment required for an atomic is stronger than the alignment required for a non-atomic load. So
Yeah.
if you have one of those architectures,
Yeah.
you may have an alignment of like 4, but if it's atomic, it needs to be aligned to like 8 or something like that. So
Yeah.
that's why it's a separate type, or one of the reasons anyway. The other reason is that sometimes it goes through like a library because not all types can actually be represented natively, and they actually need to keep track of like the addresses of the objects and stuff like that.
So there's
They like
not a
emulate it.
mention here of alignment, which itself is an interesting topic. Multi-byte, yeah, UTF-8, and what to do with strings. Okay, I agree that strings are screwed up. Thread locals. Why are they? And then time. No, time is like fine. There are good libraries to do time. It should not
Mm,
be. I'm not pulling time out of libc for sure.
It,
yeah,
it,
I mean, if you wanted to have a proper, good foundational operating system or system layer API, I mean, you probably want like the I/O networking
Yeah.
and threading stuff from the operating system,
You do need to, yeah, I
and
mean, Ryan's right. You do need to do something with atomics to do cross-thread communication that's fast and efficient,
and
but may
yeah,
require special things like alignment.
and and next to it, you probably want all the timekeeping and calendar stuff
You
provided
want them
also
in a
with
standard
an
library, but they're nothing
no,
to do with libc.
also
sorry,
there's
no, and then so what I'm saying is basically you have like the parts which are like if you want to have a sound system layer API, you have like the parts that are directly linked to the operating system, and then you have like two big chunks of things. One is Unicode and one is timekeeping and calendars. And the reason why you want to have that as a guaranteed API layer or ABI layer that's guaranteed to be there and guaranteed to say
Yeah.
how the API works is that otherwise every application ships with their own stuff, which means like they have like 20 or 30 or
Yep.
40 megabytes just uh,
Oh,
additional application size because they need to ship the Unicode tables and the time zone database and all that stuff
yeah.
and all the the parsing and reading and writing of all that information, that's something that should be provided by some systems level API. It doesn't have to be the kernel itself, but if I'm running on an operating system in 2025, I want to have some kind of API where I can say, okay, what's the time zone in 2027 in Hawaii?
Yeah.
Or
No,
is this
I'm
letter
agreeing with you
or is this
that
letter uppercase or lowercase and stuff like that without having to roll that all myself.
so I
It's
agree that this should be shipped as part of a standard library. Um, if I'm looking for what I
I,
find difficult to get without libc, the libc provides it, few other people do. Times that's not true. I get times from all kind of other places. There's great time libraries floating around. I'll grab one. Has nothing to do with libc. I don't care. Meanwhile, if I want to do something about IO, I'm heading for libc until I get a sort of a serious somebody has a serious over layer
mm,
over the OSs,
yeah.
which libc does
Um,
IO.
I think that the point I wanted to make is that, of course, my language should support timekeeping and Unicode in its
Yeah,
standard library. But my standard library that provides this functionality should just be a thin wrapper over the ABI the platform provides. Basically, the only thing my standard library does should
okay.
be a translation from the thing that's pre-installed on the system I'm running on to an idiomatic API in my language.
I'm I watched the evolution of time in Java, and it got settled out. In fact, Oracle or Sun eventually picked up the right folks' time library, but no one was providing the necessary low-level details on any OS. They were all different. They all had their errors. The damn I can't remember the name of the library now, but there's some common library that showed up that just covered
TZDB,
all the
yeah, yeah.
bases.
Yeah, Java time, like the Java runtime ships with its own
It is
time
now, right? No,
sign, time zone database derived
right.
thingy,
Yeah,
and the library knows how to read in a time zone database file and process it in a way that's like internal, like
and I
some
guess
internal
I'm saying I
format.
couldn't when that came out. It was super helpful for Java, and you could not rely on getting that from any OS directly. So Java wrote their own.
Yeah, sure.
And I don't know, is that true now that I can expect on Windows, Mac, and Linux systems
Um,
that I have the same kind of time info directly available from the OS?
I mean, the TZ DB thing is very, very widespread. I think on
That's a piece of it.
Microsoft,
Yeah.
they are still doing some of their own stuff, but I think all the data is more or less in sync with the time zone database stuff anyway. And I mean, the time zone database is also shipping on most Linux systems, probably more than once. And all I want is like have like the a time zone database file somewhere and a clean platform API on top of it, so I can request or query information from it without having to write a parser for the time zone database format in my language, or uh, that no language author should have to re-implement that parser in their languages.
Uh, it could be. That one, it'll happen or it doesn't. No one should, and yet here we are. Um, yeah, fine. There are things here that libc that I would expect to lean on, like set jump, long jump, for implementing a virtual machine. The
I
one
wouldn't.
in Java uses set jump, long jump to recover um, segvs, so the compiler can emit load ops that null check by expecting the segv if you're past a null. And they use set jump, long jump to get basically a long latency jump if the load address is null. And so it generates better code in exchange for some really horrific, complicated things. You know what? But you don't need set jump, long jump.
You can use exceptions,
No, that's how exceptions get made. That's what I'm saying.
sort of.
You have to build the
Not
exception.
not literally, but yeah, they use the same underlying principles as set jump, long jump. I mean, at least the C++ ones.
Oh,
I don't know
okay.
how Java that works.
Yeah, no, the Java one does the set jump, long jump to recover from OS level exceptions, like the SEGI I was just talking about. There's some others. And then after that, it has its own stack management. And so not part of Libc and not part of C of any kind, he switches to stack management where he pops frames away and adds frames and rewrites frames on the stack. And he knows how to do stack frame rewriting for all these architectures and all these OSs. And so that's a big chunk of work that's only necessary if you're headed down that path of a giant complete OS layer over virtual machine.
Mm.
And libc is not helping there.
But yeah, I did want to bring up the atomics, if this is okay.
You mentioned that, yeah.
Because I got some examples in the chat here, but basically, the nutshell is that there's a couple different restrictions that C++ had to impose on like atomic references to make it work on all architectures. One of them being like, so this is like atomic ref, which lets you access something that's not atomic as if it was atomic.
Oh,
But like
okay.
one of the things that they had to impose on this to get it to work on all architectures, not only was that alignment thing that I mentioned, right? So there's like std atomic ref int required alignment, which might be a different value from like int's regular alignment.
Yep.
And then there's also the fact that you have to access the atomic through the atomic ref for as long as the atomic ref exists, because if you don't do that, then it causes a bunch of race conditions on certain architectures where you need like special synchronization instructions between the two, and they don't really mix together all that well. And
Right.
so like the destruction of the last atomic ref like syncs it with the non-atomic state.
Yeah, in the land of Java,
How
atomics were baked into the language, which means they got baked into the compiler who
Yeah,
totally understands what the
it
limitations are.
works. See, the thing is that the simplified model that this guy's talking about works on x86, but it doesn't work on some of the weirder architectures. Like
Yeah.
I think Itanium, if I
yeah,
remember correctly, was one
uh,
of the ones that
but my question would have been immediately regarding the C++ approach. How old is the youngest architecture for which we are building these workarounds? And if the
Oh God.
architecture is not younger than 30 years, then I would have just said screw it. But we know it's C++. Uh,
Right.
every obstacle they encounter is a new opportunity to fall on their face for them. So
I did the Itanium port, by the way, which included all the atomic shit. Um, that was the compiler knows everything about your hardware in order to implement atomics in Java. And
how did they compare to x86?
it's whatever you did, you did. It was a lot easier to write Java atomics now as a user of the atomic libraries. The way the hell easier. And I'm talking about the Sun Misc unsafe stuff. The atomic wrappers added some overhead and added some safety and ease of use on top of that. But you could use Sun Misc unsafe, and it would do straight up normal atomic things on every platform the correct way. Um, in the implementation strategies, the JIT had to JIT out different code sequences for different people. He could force alignment. Um, and in the implementation of Hotspot itself, which is a big ass C program for which none of this atomic shit existed at the time it was written, we just had platform specific pound includes that did the right things on each different platform for doing a canned set of atomic operations. So atomic increment, atomic compare and swap, atomic whatever, this ordering between reads and writes. There's like a dozen things you had to do, half a dozen, not very many. And every platform had a pound include atomic OS CPU specific pound include you grab that did those things.
Mm.
And the shared code would pull out that piece and do the thing. So if you
Yeah.
needed to have a counter that was going to be aligned, so you could do an atomic update on it, and such things totally existed, then somewhere there was a spec that you had I have an atomic int here, I pound included whatever atomic int is, and on some platform it would have been 8-byte thing, and some would be 4-byte. or it'd be 8-byte forced alignment or whatever. So we manually did it for hotspot building itself. The JIT totally understands it. So if you write Misc on safe code, you'll get the correct answer. But here it's like you have to. I guess I don't know. It seems way more complicated than whatever we ended up with. I'm trying to look. So I claim Java did a good job here. It was one of the things I first came in at. C2 first showed up in 1.3, but I had it running in 1.2, but no atomics. 1.5, between 1.3 and 1.5, we realized that multiple processors were the thing, the new norm, that everyone had to deal with cross-thread things, that the VM was just getting by with potluck and was dying constantly on different hardwares. Like we would have bought a two processor system from Compact. It had the memory models depended upon the motherboard. You bought a two processor thing from Intel and you bought one from Dell, and they all three had different memory models because the actual cross-core communication depended on how the motherboard was wired up. So the OS, well, the JVM was dying kind of constantly once we started putting multi-threaded stress tests on it because the communication between cores was behaving differently on Compact versus a Dell machine. Would crash on mine and not on yours, or vice versa. It took us forever to sort out what was the minimum needed you had to have, and then how you got it. Then Intel came along and said, "No, we own all the cross-core communications. You have to buy our motherboards so that we can we can produce a memory model." Sun Hardware was going through the same deal with their Ultra Sparks and high core counts and trying to come up with memory models that were usable. Um, it was a giant confusion about how to deal with things. And what we ended up was the implementer of the JVM needed to have certain core knowledge and had fine grained operations, which we typically didn't do like standard colon atomic ref. We had an intent. We could put the word volatile on it, but not atomic. But volatile didn't do shit on a C compiler. So you had to force it to be not in line with something. So you did some screwing around to force the thing. The JIT itself totally understood atomics at that point. It took a while to get there, but I got to the point where I totally understood atomics, and so I would just emit the right code. And it wasn't actually too hard. It was an alignment thing, but everybody screwed around with alignment, and by the time it got to the JIT, the alignment was picked up by the VM internally. He padded as needed. He would ask the same questions I would of the port. Wait, what's the minimum alignment here? And he would get into minimum alignment for an atomic and then say, okay, alignment done. And then do I need to have, I had barriers. C2 has barriers to this day in the IR directly. And they force ordering of atomics accordingly. And then on some platforms, those barriers are no ops. And on some platforms, they're not. So on x86, they're mostly all no ops. And on Titanium, they're mostly not no ops, and actual op has to be emitted. But they do the right ordering thing. So we could end up, you can get a better answer than this. How about that? There's a proof of existence of a better answer.
Well, before you claim better answer, remember you have to be better. You have to now say how is your support for heterogeneous compute atomics? How is your support for GPUs? How is your support for NPUs?
You're
C++
right.
has to support all of those cases. If you don't support GPUs, you don't count as a programming language in 2025 for the use cases that C++ is used. So
yeah, that's
there is that.
entirely fair. Entirely fair. That is a goal for C++. It was never a Java goal. Yep. So I'll retract. We did a good job for our use case, and C++ has different use cases here, and
I'm
they
watching
look.
OCaml with interest because I think OCaml does overlap with Java's use cases, and they do seem to care about those things and solve them in an interesting way. The IO library in particular, I think they are the only relatively major programming language that is trying to support both the Linux IO, Uring, and Windows overlapped IO. And that's not common, I have to admit, to have some layer of abstraction that works well with both.
Oh, it works well on them both. So that could
Yeah.
be. Yeah, I don't look at OCaml enough. I keep thinking it's this custom thing for Jane Street and functional programmers, but they keep piling money and development time on it, and I keep hearing that they've done really good work, really good job. They probably have. I just haven't looked.
Yeah.
Yes, that's a thing I should have done 20 years ago. Was called up Jane Street and said, "Okay, I'm not fond of functional programming OCaml, but I can probably implement really cool OCaml." That would have been woulda, coulda, should have been a good thing to go do.
And it seems to be a fairly pragmatic programming language. At least as far as I see the code written with it, it's not nearly as pure as some Haskell subset. You really don't need to know what you say pro-functor or a monad. I mean, you can write relatively straightforward imperative looking code in OCaml. So it seems to be kind of, maybe it's just me, but it seems pragmatic in a sense.
I
And of
would
course, Haskell also has internal diversity, to be fair.
I would think that for Jane Street to reliably use OCaml for 20 years and run a business where it's a core piece of their technology, they would have to have it be they would make it pragmatic. It would get there. So yeah, totally believable. Well, okay, fine. Are we done with fun with atomics and or random things? What you can and can't avoid out of libc? Um, anything else? I have my usual story here since I'm now running the household. I also have a shit ton of work to be done. Uh, let's see if I can't shoehorn my wife into the car and take her down to the beach. That would be a fun thing to do the rest of the day. And then grocery shop, and then we got to run by AAA and get a re-update on the hang tag for handicap
You're
spot.
just trying to get out of your household work.
It's true. No, there's a ton of things I have to go do. And maybe I can make some of them fun, and but oh god, I just got to get a deal. Fine. At some point, I do work to get paid, so it's fine. All right. In the deathly silence, I'm going to call it. Um, that was a fun conversation. That was good. A bunch of fun things went around there. So, till next week. And I think
Bye.
next week's on. What are we doing here?
Have a
Should
good
be on
weekend.
for the normal. The week after is like the day after Christmas, and I'll call it next week whether or not I'm here on Christmas day after or not. Okay, so we see people later. Bye bye.
Bye.